Hello, everyone. Welcome to the Tech Diva, where we dive into everything tech with a sharp focus on DevOps tools and real world practices. Subscribe and let's practice together. Ciao.
Hello everyone, my name is Marjorie, and for today we'll be looking at implementing Lambda for EC2 resource lifecycle and management, and then we'll be using Terraform to create Lambda functions that will manage EC2 lifecycle and log creation events like S3 resource creation in S3 and secrets manager. So we actually have two Lambda functions provision or rather written for modularity's sake, and this first one writes the logic to manage EC2 lifecycle by using the cost explorer to send Mattermost notifications actually when certain events occur. It uses the cost explorer and it watches it for the last 3 days, and if based on these environment variables declared here, if the cost exceeds a threshold of $5, it's going to send a notification, and it also looks at the max age for the EC2 running EC2. If it exceeds 4 days, it's going to send a notification. It also looks at, or rather, it helps to enforce resource tagging. So if your EC2 instances don't have these tags, owner and environment, it's going to send a Mattermost notification as well. The second .py basically is going to send Mattermost notifications as well when resources like S3 buckets or secrets are created. It's going to extract information like the time of creation, the resource created, the user identity creating, and send as logs. Okay, so we'll jump right into our main.tf file. And we have the first block basically zipping up the Lambda functions into a zip file. We have the Lambda handler provision here, and uses these environment variables which were declared in the Lambda function previously, and we have the variables declared here as an object variable because they serve one resource basically. And okay, if you go down below, this Terraform code ensures that the CloudWatch log is retained for 30 days. We have a resource logger or a code that ensures or enforces tagging of EC2 instances. And then we have an event bridge for the EC2 lifecycle provision here, and watches the CloudWatch and triggers once a day, 12 a.m. UTC time. And below we have our target for that event bridge, which is the EC2 Lambda. And below we have event bridge rules provisioned for bucket creation events. We have that for secret creation events. We have the targets, the S3 logger and secret logger. And then we have permissions, basic permissions to invoke the Lambdas, event permissions. We'll jump into our IAM rule, which declares the role, the Lambda rule that the role that the Lambda is going to assume. And this rule has it points to, in this block, it points to these policies, a custom policy that basically gives it the permission to, in the Cost Explorer, it gives it basic EC2 permissions and logger permissions, right? It also has basic Lambda execution permissions here to execute the Lambda function. So this basically provisions the Lambda rule, right? And then next is what else here? We have our provider.pf, we have our variables.tf, we already talked about that. And next is our resource. Let's go right into provisioning, the actual provisioning of the resource. So we have our resource looks at an environment variable that is declared above, right? We use the YAML to declare our values for our variables and fetch them centrally from this location, right? So rather than write various Terraform.tfvars files for various resources, we have all our resource variables or values declared here, and we centrally fetch them. So for Lambda, its point is going to look at, via this path, it's going to look at the YAML files above, right? And then we have the Terraform version declared here and the provider versions and all. And then our state file, is provisioned already and is going to track whatever resources we are going to be provisioning here. And this block points, it declares a source, right? And the various variables we'll be using for this particular provision. So we'll go to we'll try to run our Terraform commands. Okay. So we're going to be using a role rather than a user in a sandbox account. Yeah, so would, let's see if our role is still active. AWS SDS get color. And if it's not, we'll just get the credentials. We try to get fresh credentials for a role, already provisioned role in our sandbox account. Okay. Okay. So we have to get credentials to okay. So we have credentials to federate into our role. And to do this, rather than export these values individually, I prefer to run the command together, right? So I'm just going to copy these credentials and paste. Okay, copy and paste right here. Hopefully we don't miss anyone. Go back here and get the secret, the session token. Here. Okay, so we are good. So we're just going to copy all of this to export those credentials in our terminal and have a role. Did that go? I guess not. Okay. All right, so let's find out that the role is active. Voila, we have a Terraform session role active. So we're going to run a Terraform init. Oh, we have to cd into a resource block, resource directory, and into a Lambda directory as well before we Terraform. Hopefully it doesn't take too much time. And hopefully we don't encounter any setbacks to make this video longer than necessary. Okay, so we have an error here. While installing HashiCorp, I could not query provider registry for Terraform. Failed to return authentication, check some provider, the request failed after 2 attempts, please try again. Hopefully we don't have network issues. Let's try again. Okay, so we successfully initialized. Let's Terraform validate and make sure that our codes are okay. Okay, so we are going to Terraform one. Okay, so we have an error, archive creation error. Oh, archive. We have issues creating lambda.zip. Error creating archive, error archiving directory, could not archive missing directory. Why? Let's have a look. Let's have a look at main.tf. Our first block is supposed to archive these two Lambda functions, and the source directory, the path to it is, that's it, Lambda function. We have, it's looking for Lambda function, whereas we have Lambda functions. Okay, so we just rename this, rename that to Lambda function, yeah? And hopefully that should be good. Let's have that saved. Let's have that saved and we run our Terraform plan. Okay, we have our Lambda zipped, Lambda function zipped. Okay, great. We have the plan to provision 17 items and 0 to change, 0 to destroy. So we'll just go right in and Terraform apply our code. Okay, we'll say yes. Prompted to approve. So we have our resources being created, our Lambda functions being created. Okay, so we have our Lambda functions provisioned via this Terraform configuration codes we wrote here. And eventually we're going to Terraform destroy because it's just for demo purposes. So thank you all for watching, and we look forward to bringing you more projects that we are working on. Thank you and bye.